It is of analog electronic subject. In specific, it belongs to diode circuits and its applications. As per the question, there is a voltage source which has the supply as 120 volts RMS at 60 Hz. This supply is given to a transformer primary, and the transformer primary and secondary are connected by the relation 10:1. This is the conversion factor. The output of the secondary is given to a bridge rectifier, and the bridge rectifier is fed, the output of the bridge rectifier is fed to a load resistance of R1. We need to find the peak value of Vout. So in here we need to find the peak value of Vout. From the given data, we see that the input is 120 volts RMS 50 Hz. Hence, the input that appears at the transform primary can be written as 120 volts RMS, and it has a peak value of 120 root 2 volts. And the output that appears at the transformer secondary can be written as 12 volts RMS because of the reason that it is at 10 days 120 divided by 10, and hence this can be written, and this corresponds to a peak value of 12 root 2 volts peak. So the input that appears across the input terminals of the bridge rectifier is as shown, and the output that appears across the output of the bridge rectifier can be drawn as. This is because of the reason that during positive half cycle, the bridge rectifier's output VO is equal to Vs, and during negative half cycle, the bridge rectifier output VO is equal to minus Vs. From this, we see that the peak value of the bridge rectifier output is equal to the peak value of the bridge rectifier input. As the peak value of the bridge rectifier input is 12 root 2 volts peak, the peak value of the bridge rectifier output voltage can be written as Vout P is equal to VNP is equal to 12 root 2 volts, which is upon simplification approximately equal to 17 volts. From this, we see that the correct option which represents Vout, peak value of Vout is C.